Hi and welcome to example 4. Here we have an outdoor process handling benzene. Benzene is a hazardous liquid that is highly volatile at room temperature and evaporates into the air very quickly. Its vapor is heavier than air and may sink into low-lying areas, thus affecting the classification extent. The most likely source of release in this process is the pump seal. When a leak occurs, benzene will pool within the pump containment, creating a pool release scenario. Let's use ExHAC to classify this hazardous location. To start the hazardous area classification, we first need some information on the location of the pump. Let's create a new project and enter the required information. We will name this example benzene pump application. Next, we will select the compounds involved in the release. Search for benzene in generic compounds. And since it is already there, we don't need to create a new compound. Next, we go to FM and create a new mixture for benzene, since it is not found here. Enter 100 in mole% of benzene and click Save. It will appear under the Custom Flammable Mixture section. Next, we go to the FM Analysis tab. Benzene is not listed, so let's create a new FM analysis. Select benzene and click on Start Analysis. The parameters for benzene will be displayed. Now, we need to create the source of release. We will name this SOA benzene pump application. This is a liquid pool release, with the pump seal being the most probable source of release because it is a moving part in service. Let's assume that the stream is running at a temperature 60 degrees Celsius and a pressure of 500 kilopascals. The grade of release will be secondary. The ambient temperature will be 32 degrees Celsius. Click Submit and the SOA will appear on the SOA list. Since the pump is located outdoors, in a freely ventilated location, we do not need to create a new enclosure. We can go directly to the HAC analysis. To start the HAC analysis, click Create HAC. Select example 4. Benzene FMA. Benzene pump as SOR. And leave the enclosure as non-enclosed. Click Configure Analysis. Let's review the HAC analysis parameters, and override any parameters if needed. Given that this application does not incorporate spill containment, we will have to make some assumptions related to the size of the pool release. This will be a function of how much fluid we expect to release under normal operation, the permeability and the slope of the surface the spill will collect on, how close the equipment is to a drain system, and how often the equipment is physically monitored by operations. In our example, we will assume a spill onto a concrete floor, with a 1-degree slope to a saw drain, located 5 meters away from the pump skid. We will assume a 1 meter wide spill size, resulting in a 1 by 5 meter pool of 5 meters squared. Let's enter 5 meters as our pool surface size. For wind speed across the pool surface, Table C.1 from the IEC standard recommends a 0.1 meter per second for obstructed areas. We will define the availability of ventilation as fair, given that it is installed in an outdoor location in a congested area. We can leave all other parameters as is, and press Start Analysis. Now, let's go to the ExHAC Output tab to view our results. We see that ExHAC has calculated the mass and volume vapor release rate to atmosphere, based on a stream vapor pressure of 52 kPa. The release characteristic indicates a medium degree of dilution, resulting in a Zone 2 classification surrounding the source of release. A horizontal release extent of 3.41 meters, with a vertical extent of 1.61 meters, is indicated. To view our report, we go to the ExHAC Analysis List tab and select our hydrogen compressor application, and click on Create Report. An Excel report output will look like this. We can apply this information to a diagram to fully document our hazardous area classification design. We expect a pool release to have a release shape similar to Figure 0.5 from the IEC standard. The shape will have to consider the shape of the pool release we expect to see. Let's apply this information to our benzene pump skid application. The ExHAC diagram will look something like this. A vertical extent of 1.61 meters, with a horizontal extent 3.41 meters, is applied from the source of release. Note that the classification also considers the distance from source of release to the drain, where an additional 3.41 meters is added beyond the drain to account for the flow direction of a release. The group classification was defined as Group 2A. And the auto-ignition temperature defined as 498 degrees Celsius, corresponding to a T1 IEC temperature code. Our hazardous area classification design, for this benzene pump application, is now complete.